Let's talk about channels, right? And if I want to talk about a channel, obviously we're going to have to make a channel. So let's make a channel. Okay, so I made, this is by definition unbuffered channel, right? So this is a channel that does not have a buffer. If you want to make a channel that has a buffer, you would do something like this, right? So this is a channel with a buffer of 1 or a buffer capacity of 1. And if we make a channel that has no buffer capacity, so for example, something like this is going to be an unbuffered channel. They are actually very distinct in how they work, so make sure you know which one you're using, right? Okay, so let's say I make a channel which is unbuffered like so, a very simple channel. And what I'm going to do is I'm going to push into this channel a string. I'm going to say I'm going to push into this channel hello world. Okay, so we passed into this channel hello world, right? And what I want to do now is I want to pull something out of the channel. So I'm going to say fmt.println, and I'm going to pull something out of this channel, right? So before I continue, I'm going to just let you know this program is not going to work, right? This is going to give you an error. And I'm going to explain why in a couple seconds. Okay, so let's see. Fail error, all routines are asleep, dialog. Okay, so the problem here is that we made an unbuffered channel like so. This means that this channel has absolutely no capacity whatsoever to store anything. So when we push, or when we try to push something onto the channel, so this is going to block, right? And if it blocks, then we're not going to be able to execute this line. And if that happens, Go has a very nifty deadlock detector, which is going to give us a fail error, which is nice. Sometimes it's not very nice. And once it blocks, there's actually no place to go, right? So this cannot execute. And if that happens, then Go is just going to give us a deadlock error. And the way you fix this is simply, well, I mean, in this example, how you can fix this is you can just simply make this into a buffer channel like so, right? So if we make this into a buffer channel, then this string is going to get pushed into this channel, and we're going to go to this line 8, and it's going to pull something out of this channel and print it out. So let's actually test this. All right, so we got hello world. Awesome. So before I continue, I want to show you that you can actually get a few properties from your channel if you need to diagnose it. For example, you could print out the length of your channel like so, and you can also print out the capacity of your channel like so, right? So the length is how many things are in your channel, right? And the capacity is simply how much your channel can fit. So as you can see, at this point in time, when the program was executed, the length of the channel is 1 because it had one thing inside of it, and the capacity of the channel was 1 because that's how big the buffer is. If we print this after this line, as you can see, we got a length of 0 because there's nothing inside this channel anymore, and we got the capacity of 1 because it can still fit at least one thing inside of it. Okay, and the next thing I want to show you is how to use Go routines. So a Go routine is, I think the simplest way to explain it is just like a non-blocking function call. I guess like for now, this is a good explanation. So you can run Go routines like this, right? So it begins with the word Go, right? And then you can either define a function here or use a predefined function. So I'm going to define an inline function like this. And what I'm going to do here is I'm simply going to push hello world into this channel, right? And to show you that this is a non-blocking, so the key point here is that this is non-blocking, right? The key point that this is non-blocking, I'm going to demonstrate this by making a buffer channel like this, and I'm going to push something into hello world, right? And down here, all we're going to do is we're going to print out whatever was pushed into this channel. Okay, now that we know how to do that, let's do something a little bit more sophisticated. So let's say instead of just printing out one thing here, what I want to do is I want to pass in, let's say, 2 things. So I'm going to say hello world, and let's pass the next thing as goodbye world. Right. Okay, so what I'm gonna do here is, instead of just printing out the first thing and then the second thing, and let's be completely honest here, you can do this no problem, right? So if I run this, as you can see, we got both things back, right? So, but like, think about it like this. What if I have like a million things here, right? What if I'm pushing onto the channel like a million things? All right, so what we can do is we can do a for loop like this, and we can actually arrange over this channel. And this is actually gonna give you an error. Let's just call this v instead. Okay, so what I'm doing here is I am arranging over the channel, right? I'm getting hello world, goodbye world, but this will give us an error, and I'm going to show you why. So we got a deadlock, and why is this happening? And to actually explain why this is happening, I think I'm going to go back to a more simple example of the channel. So what I can do is I can push something into the channel. So for example, I'm going to push hello world again, right? And let's make this into a channel with a buffer of 1. And when I push something onto this channel, right, it's in here, right? It's in this channel. So if I then pull something out of it, so for example, if I do fmt.print line, so if I pull something out of the channel, it's going to be fine, right? It's just going to print hello world. So let's see what we get. Okay, so we got hello world. Now, if I do this again, now keep in mind, there's absolutely nothing in this channel anymore, right? As you can see, we got fatal error, all goroutines are asleep. So this is happening because you're trying to pull something from this channel, right? But it doesn't have anything. And if it doesn't have anything, it doesn't really know whether or not in the future it's going to have something or not, right? So you're just going to block here and wait until something gets added to this channel. Let me give you a better example, actually. So if I make a go routine like this, and what I'm going to do here is I'm going to sleep for let's say 2 seconds, right? And then I'm going to push something onto this channel, and then I'm going to push something onto this channel. As you can see, we got hello world, right? So with this go routine, it's going to try to pull something out of the channel, right? And if there's nothing inside this channel, it's just going to sit here and block until something becomes available. So for example, with this example, what I did is I waited 2 seconds and then I pushed something onto this channel. But while this is waiting for 2 seconds, this was sitting here and blocking, waiting for something to get populated, right? So if we do like a for I is equal to range ch like this, right? And then we, I don't know, print this out. So it doesn't know whether or not there's going to be something here in the future. So to indicate to this for loop that this channel is closed, I suppose, or there's nothing else that is going to be pushed on this channel, what we can do is we can do close ch, right? So if we close a channel, let's run this. As you can see, we got nothing back, right? So what happens when you close a channel, right? So let's say I close the channel and I try to receive something from the channel, right? What do I get? We get nothing. Okay, let's actually assign a couple of values, right? So let's assign v, and let's print this out. So we basically got nothing, right? So let's do something else. Let's assign it with an OK, right? So when you try to pull a value out of a channel and the channel is empty and it's closed, it is going to return to you an OK which is false, right? So let me show you. As you can see, we got false, and we got some like empty string here. And if we push something onto this channel, so for example, if I push onto this channel just an empty string like this, it's going to give me a true, right? So because when you push an empty string onto this channel, it receives on this channel, right? So I receive something on this channel, and it's going to populate this value, and it's going to populate the OK. And if I received something that was passed on this channel, then the OK is going to be true. While if I receive something which is just the default value due to the channel being closed, the OK is going to be false. Okay, so I think that's enough for ranging over channels. Let's talk about something else. So let's make a program which simply passes a message back and forth between two coroutines. So let's say I want to build two coroutines. So I'm going to make one coroutine. It's going to be func. And let's build a second coroutine. And let's make a channel. So I'm going to say channel is equal to, I'm just going to make this a string. So what I want to do here is I want to have this coroutine pass a message down to this coroutine. And then when this coroutine down here accepts this message, it's going to send a message back to this coroutine, right? So this is going to be like a little ping pong application, right? So what I'm going to do is I'm going to actually begin here. I'm going to pass a message into this channel. I'm going to call this ping, right? And then all I'm going to do is I'm going to receive on this coroutine and we're going to put this into for the for loop. Okay, so now that we have that, we're just going to take this, put this right here, and we are going to switch the order, right? We're going to receive first, and then I'm going to send. And I'm going to send a pong, right? Actually, yeah, I'm going to send a pong. So here we're sending pong, and here we're sending a ping. And this should work, right? Let's try it. And as you can see, we got nothing back. So what's happening here, right? What's happening is that we started this coroutine, right? That's fine. Then we go down and we started this coroutine. That's fine. And next, what this thread does is it finally exits the program right here. And that's why we are just exiting the program as soon as we run this, right? So to fix this, you can do a couple of things, right? The simplest thing to do is simply write a naked select like this. And this is not the ideal way to do this, but this is an infinite loop, so it's not really going to do anything, right? I'm going to explain select later. Okay, so let's actually run this. So as you can see, we got, I'm not sure if this is like picking it up fast enough. Let's add a little sleep. Okay, let's try this again. Okay, so we get ping pong, ping pong, ping pong. Okay, perfect. So this program works, right? Okay, so now I think we have to start talking about the sync library, which is really, it's a very coroutine and channel adjacent, if that makes sense. So let's say I have a for loop. And let's say what I'm doing here is I want to start a coroutine, right? And this coroutine is not really going to do anything fancy. It's just going to print out hello world. And if you want to be fancy here, you can also include this I, just so we're using it. Whoops. Okay. So let's say I have this for loop, right? This for loop, I goes from 0 to 9, right? And it starts a coroutine for every iteration. That's pretty simple. And I think we all understand what's going to happen here. If I run this, this is just going to end the program and you're not going to get any prints, right? So let's actually confirm that this is actually true. And as you can see, we got nothing, right? I think I showed you this before, but you can use a select like this, right? And make it select. This is not ideal because this will give you a deadlock error once all of these coroutines are finished. So let's see how that works. Okay, so we got deadlock, but all of our coroutines did finish successfully. Okay, so Golang has a very nice sync library, right? And the sync library has a struct which is called waitGroup. And this waitGroup is actually a very simple construct, but it's actually very powerful. So what we can do here is we can do wg.add, and we're going to add 1, right? So for every coroutine we start, we're going to add 1 to this waitGroup. And inside of this coroutine, when it's finished, we're going to do wg.done, right? And in fact, it's actually safer to add a defer like this. Okay, and finally, what we're going to do is we are going to do wg.wait. So what's going to happen here is we're going to add 1 for every coroutine we start, right? And here, inside of this coroutine, once it finishes, it's going to call wg.done, right? And this wg.wait, this is going to block, so blocking while greater than 0, right? So what's going to happen is this is going to block while the counter inside of wg is greater than 0. When it hits 0, it's going to become non-blocking, and it's just going to allow this program to terminate. Okay, so let's actually run this. As you can see, we got hello world back 10 times, and we didn't get any deadlock issues. Okay. So in this video, I've used select at least twice, and I haven't really explained it. So let me try to explain how select works. And I think the best way to explain how select works is if you have multiple channels that you're passing things on. So let's make 2 coroutines, right? So let's do go func. And what I'm going to do here is I'm going to sleep for 2 seconds. And I'm going to pass on channel 1. I'm going to pass on this hello world. Actually, yeah, actually, let's just pass on it like ch1. Right? That's simpler. And there's going to be infinite for loop. Okay. And let's actually do the same thing down here. And let's make this pass every second. And let's change this to 2. Okay, so what's happening is we have 2 channels, right? And what we're doing is we are going to pass infinitely every 2 seconds on channel 1 the string ch1, right? And on channel 2, we're going to pass every second ch2. Right? That's pretty simple. And here, I'm going to make a select. Now, keep in mind, a select is something which is blocking, right? It is going to block like so. So this is going to block until it receives something. So if it receives something from channel 1 or channel 2, it's going to get that, and I'm going to show you how, and then it's just going to allow the flow of execution to continue. So let me show you. Okay, so we got channel 2, right? And that makes sense because channel 2 is going to pass every second while channel 1 is going to pass every 2 seconds, right? So this is actually a very popular pattern in Go, but you can do infinite select. So you can do for, and then instead of this for, we're just gonna have the select, right? So this infinite for loop is just gonna continuously select things. So what's gonna happen is it's gonna select either with this or this, then it's gonna loop again, and again it's gonna select this or this. Let me show you. We got channel 1, channel 2, channel 2, channel 1. So as you can see, the slower channel still is able to pass things out of it. So the next thing, so another thing you should be aware of is the default. So you can do default, and here what we're going to do, so here what we're going to do is going to say fmt.println nothing for now, right? Now keep in mind this is actually going to consume a lot of compute. So if this is not the case and this is not the case, then it's just going to default to this default, and this default is going to get printed a lot. So let me show you. So as you can see, we're just getting this string over and over again. Let me just stop that. Okay, so let's say I want to make a little silly program, right? So let's make a program. We're just gonna loop for 1,000 times, right? And in this program, I'm gonna start a Go routine for every iteration. And let's create a variable. And what I'm going to do here is I'm going to increment this I inside of this Go routine, right? If you know anything about Go routines, you will know this is not a good idea. Anyways, so I want to keep it simple, so I'm going to say time.sleep. I'm going to sleep for 2 seconds. Okay, so what I'm going to do is I'm going to increment this up to 1,000, right? And finally, I'm going to print this out. Okay, so this is a little strange. Why did we get 968? We looped 1,000 times, right? And we incremented I by 1 every single time. So did something happen? Did a couple of these Go routines not work? Like, what's the problem here? So the problem is that we are trying to do a parallel write on the side, right? And we're writing from all these 1,000 Go routines at the same time. So naturally we can have some data corruption. And to fix this, we have a very nice data structure from the sync library called a mutex. So a mutex, basically what it does is it tells your program that when you do a mutex lock, so when you run the lock method on this, no one is allowed to touch anything after this until you call m.unlock, right? So you lock something, no other thread is allowed to touch anything that comes afterwards until you do m.unlock. And yeah, okay, let's test this. So as you can see, you got 1,000, right? It's also a very handy thing you can do in Golang, and that is, if you are unsure, right? So if you're unsure if your program has a race condition, you can do go run -race, and it's going to actually try to analyze it and see if that's the case. So as you can see, we do have a race condition. Let's try this with the mutex again. So this race detector is actually very sensitive, so you do have to do .lock down here as well, just in case. Okay, so let's run this again. Yep, so as you can see, we got 1,000. Perfect. So another thing I want to show you is how to use the read-write mutex, and I think I think this is actually a very interesting way of. So here's the thing. This is a more of an advanced topic. So if you don't feel comfortable with mutexes so far, you may kind of run into issues and bugs if you use the read-write mutex. But let me just show you like a basic example of how it works. So let's say I have a read-write mutex, right? I can either do read-write mutex lock, right? So I can lock something, or I can do a read lock. So the difference between a relock and a lock is that a lock is something you use when you plan to write something, right? So if you plan to like increment a variable like so, you may want to do a lock, right? If you are going to simply if you're simply going to read something, so if you're just going to do like print line I, something like this, right? You may want to use a read lock. Why is this? Well, simply because when you read lock something, it can still be read in parallel, right? But if you lock something, it cannot be read in parallel. It can only be read in series. So let's say I have a for loop, right? And I'm going to do this, I would say like 10 times. And what I'm going to do, actually, I'm going to also need a wait group. So I'm going to say sync.wait group. Okay, so I have a read-write mutex and I have a wait group, right? So what I'm going to do is I'm going to start a go routine, like so. And what I'm going to do here is I'm going to just print out reading data, right? So pretend I'm reading some data here. And in this go routine, what I'm going to do is I'm going to say writing data, right? So here I'm going to write some data. I'm not actually going to write any data. This is just here to kind of illustrate what these go routines are doing hypothetically, right? And to simulate some work, I'm going to say time.sleep, and I'm going to sleep for 1 second. Yeah, I think that's good enough. Let's do a 1 second sleep on both these go routines. Okay, so here I'm saying reading data and sleeping for 1 second. Here I'm saying reading data and sleeping for 1 second, right? Okay, so how does this relate to the read-write mutex? Well, actually, one more thing I want to do is I want to do wg that add. So I'm going to add for every go routine I start. I am going to add 1, and of course I'm going to defer a done here. I'm going to defer a done here. I'm going to defer a done down here. Okay. Okay, so in the first example, so here, if we're reading some data, right, what we can do is we can say, okay, so what we're going to do here is going to do our lock, right? So we're going to read lock this, and once this is over, we are going to w dot so we're going to unlock this, right? And here, since we're hypothetically going to write something, we're going to do rw.lock. So we're going to lock this, and here we're going to unlock this. Okay, so now that we have that, the only thing I have to do is I have to do wg.wait. So I have to wait here. Okay, so now that we have that, let's actually run this. So as you can see, all of these reads finished almost right away, right? While the writes, actually, let's make this a little shorter, right? So let's do 3. So we got a data write, we got 3 data reads, and we got a write, and we got a write, right? Again, let me try this again. So as you can see, all these reads finish right away, and these writes are being processed in series. So, I mean, honestly, you don't really need to use the read-write mutex unless you're doing something more complicated, but again, it's nice to know. Okay, so let's say you have a problem, right? You have a problem with your code where you're waiting for a variable, let's call it flag, right? You have a variable flag, and you are waiting for this variable flag to change to something else. So you have a for loop, and you say, while the flag is like less than, I don't know, 10 or something like that, you're gonna, I don't know, do something. Anyways, right. So in Golang, they actually invented a new struct for this kind of like issue, where you may want to like constantly loop until like some variable changes. They are calling it a cond, right? So you do cond is equal to sync dot new cond, and I forgot, but you need to pass in. You're gonna need to pass in a mutex. Right. So you have to create a new mutex, pass it in, and you have this cond, right? What does this cond have? Well, this cond has the ability to lock, right? You can lock things, right? It's nice. You can also unlock things. More importantly, it has two methods, which is it has actually it has a couple of methods. It has signal, right? So you can signal something. You can do con dot what's it called again? Broadcast. Yeah, you can do like a broadcast. You can do con dot wait. Wait kind of works the way that a wait group does. So it just like waits for something until it receives either a broadcast or a signal. And so let's say I have a go routine, right? So I have go routine. So let's make a go routine, and this go routine is going to sleep for. So this go routine is going to sleep for, let's say, 2 seconds. Okay, and when it sleeps for 2 seconds, what's going to happen is it's going to set flag to true, right? And let's make a variable flag. Let's set it to false. All right, so what's going to happen here is we are just going to sleep for 2 seconds, set flag to true, and then nothing else. Anyways, so actually to use cond, let's do con.l lock con.l.unlock. Okay, so what we're doing is we're locking it, setting it to true, unlocking it. This should be pretty simple. So let's make it. Let's make a second go routine, and this is going to be a go routine that actually waits for a flag to change, right? So it's going to do for flag or for while not flag, and all this is going to do is going to do con dot wait, right? And I think what we have to do here is we do con.l.lock, and then con.l.unlock. And don't forget to run this. Okay. I mean, honestly, we can also make a new wait group. And let's add 2 here, right? Ooh, okay. What's the problem here? Deadlock. What's going on? Flag. Oh, right, I forgot. Okay. So cond dot broadcast, and I'm going to broadcast this. So I'm doing cond dot broadcast, and this is basically going to wake all go routines. It's going to basically allow this to continue. Okay, let's do this. Okay, so we got that. Let's actually add some Okay, let's actually add some context to it, right? So what's happening here is that we have this function. So we have this go routine, right? This go routine is going to sleep for 2 seconds. It's going to lock, right? It's going to change this flag to true. It's going to broadcast. So when it broadcasts, it's basically sending a signal to every go routine that's blocking here, right? So when conda broadcasts, what happens is that it basically sends a signal to all of these blocking wait function calls, and what this is going to do is it's going to allow this to continue, right? So it's going to let this continue, and when it continues, it's actually going to check if flag is false, and if it's not false, then it's going to go down here, right? It's going to unlock. It's going to go defer wg done. Anyways, actually, let's start a bunch more of these. Let's do like 1,000, right? I like doing 1,000. I don't know why. And let's do add one here, and let's add one here. Okay. Right. Let's. Okay, so I have no idea what to tell you. So I don't know what to tell you. If you like Con, definitely use it. I so far don't really have any use case for Con. So everything else I showed you was pretty useful, except for this struct. I don't know. It's a pretty nice struct, I guess. It's in the standard library. Anyways, see you later.